Okay, welcome everybody. It is 10 a.m. and we are going to get started with the 10 a.m. Etc. track session. My name is Skylock. I am your moderator and host for this session and all day in this track. I would like to introduce Cameron Presley. Cameron is a lead software engineer for Century One, a speaker, a Microsoft MVP, director of speaker relations for CodeStack, a co-organizer of Functional Knox, and is based out of Charlotte, North Carolina. So Cameron, I am glad to welcome you to the channel. Today you're going to be talking about establishing a solid foundation, an intro to software design. We appreciate that. A couple of housekeeping notes. If you are in the channel in the session, there is a Q&A section in your Teams viewer, in your web view. I'm not sure exactly where it is because I see a different view than you guys, but if you have any questions, please go ahead and ask those there. Also understand that there is a delay between the speaker and the live event. So if he doesn't answer your question right away, I'll be moderating them and I will go ahead and ask them. But Cameron, you will also be able to see them and can answer them as you like. At the end of the session, about 45 minutes in, we will open it up for Q&A. And then after that session, feel free for everyone to jump over to the Discord channel to continue the conversation. So with that, I will stop sharing as soon as Cameron, can you go ahead and share your content?
Yep, sure can. Give me 1 second here. All right, if everything's working correctly, you should be able to see a PowerPoint presentation.
I do see it, and I am sending you live right now. So take it away, Cameron.
Fantastic. Thanks so much, Scott. So good morning / afternoon, everyone. As Scott has said, my name is Cameron Presley, and we're going to be talking about solid design principles today as we establish a solid foundation. So first things first, everything you're going to see in this presentation today is already live. Slide deck, articles I reference, books, everything. You can find those resources either by going to this QR code or by going to this URL. I've also posted this in the Discord channel under a track, etc. So you can find it there. Scott did a fantastic job introducing me, so I won't spend a whole lot of time here except for say a little bit about what Century One does. If you've ever had to interact with SQL Server and you're like, oh goodness, why is this not doing what I want? Why is this query so slow? Why is the performance not so great? We probably have something to help you out. So if you're interested in doing a better job monitoring your SQL servers or doing query tuning, feel free to chat with me after the talk. I'd love to chat more about that. So what are we going to talk about in this presentation? So at the very beginning, we're going to talk about what is solid. What do we mean by solid, right? And then we'll take a look about why our code should be solid, some of the benefits we get by following these principles and patterns. And we'll actually explore all the principles throughout the presentation while looking at this fictitious bookstore application. We'll finally wrap up with some additional resources where you can learn more and really kind of get your hands into some of this stuff, because I can't make you an expert in solid in 45 minutes. However, I can give you enough tools to be dangerous so you can do your own research and your own digging. So with that in mind, let's talk about what is solid. What do we mean by that? So at a high level, solid is just a mnemonic for a set of principles that allow us to write easier to maintain code. Solid is not a JavaScript framework that came out in the last couple of years. These concepts are actually pretty well established. Most of these concepts were established in the 80s, some of them in the late 70s, but they were formally codified in this book by Robert Martin known as Agile Principles, Patterns, and Practices. So what does the mnemonic stand for? Well, solid is these 5 principles, right? Single responsibility, open close, list off substitution, interface segregation, and dependency inversion. And now that you know the acronym, you're a solid expert, so you could, stop the presentation, go enjoy your cup of coffee, but I wouldn't recommend doing so because we need to dive into this a little bit more. And I know I just threw a whole bunch of words at you, but it's okay, because at the end of the day, what solid is trying to help us, like the problems it's trying to prevent, are the 2 following concepts. It's because our code usually is doing way too much stuff in it, and the abstractions we're trying to code to or work with suck. That's really what it is. So by following solid, you typically end up writing these smaller components that compose very easily, and the abstractions tend to be very easy to work with, or at least covering what you're supposed to be covering. But let's take a look into this. Let's go a little bit deeper, shall we? So why is solid such a good idea? Why should we be following this? Well, I'm going to make an assumption in the room that most of the attendees have written code for some period of time. So that means you've done bug fixes, maybe some new feature work, things like that, right? So when you're working on code, do you spend a lot of your time reading code, or do you spend a lot of your time writing code? Well, I don't know about you, but for me, a lot of my time when writing, like when working on new features and bugs, it's actually not writing the code. It's usually reading it and trying to understand what's going on now. What was the original design intent? And this concept, I call it time to context, right? This idea of how long do I have to read code to fully understand what it's supposed to be doing, right? I think we can agree that if it takes me 3 days to understand how a component works, it's probably not great, right? Because in those 3 days, I could have done all this other stuff, right? So if the idea is that we want to be able to understand code as quick as possible to optimize for that time to context, we should probably write code in a way that kind of lends itself to that. So, and that's because the reason why I want code easy to read is because, fun fact, you're probably not going to be at your job for forever, right? Someone else is going to maintain the code you write, even if that someone else is you 6 months down the road, right? And so by following these principles and patterns, you will typically, I won't say always, but you'll typically end up with code that's easier to read, easier to work with, easier to maintain. So that's why we want to do this, right? So solid software development is not a Jenga game, right? I don't know about you, but I've definitely worked in code bases where I made this really innocuous change, should have been very straightforward, shouldn't have broken anything. And like a Jenga tower, it all fell apart, right? So we're going to take a look at these principles, but I'm not going to go in the order of the acronym. I'm going to go in the order of, to me, importance, like the likelihood you're going to run into these things. So with that being said, let's start with the single responsibility principle, right? At a high level, just because you can do something doesn't mean you should. So let's take a look at some code. So we've got, let's say we have this class called the order calculator, right? And it calls calculate total. I'm actually going to pause here for a few seconds and see how long it takes for someone to post like they understand what this code's supposed to be doing. I know it's early, I know it's a little bit of C#, but I'm kind of curious. Yeah, so this code at a really high level is really doing 2 steps, but it doesn't seem very clear that it's doing those 2 steps. But if we add some highlighting, right, we actually know what this method's supposed to be doing is, it seems like it's trying to determine a discount based on some rules, and then it's supposed to determine some shipping value by some rules. And then once you've got the discount and the shipping, it does some math to figure out whatever the total is going to be. Okay. Well, if I had to make changes to how we calculate discount, I kind of would have to go through the C of if else if to go do that. Same thing with shipping. And if I needed to add additional logic, like maybe you get a different type of like loyalty discount or whatever, I would have to try to shoehorn in here. It's not very clear. And unfortunately for the next developer, they may have to spend some time looking at this, which is not ideal. So one refactor we could do to make this a little bit easier is literally take those pieces of logic and move them to their own methods. So in this code example, we've replaced all those if checks with these 2 methods, one called calculate discount, one calculate shipping. And once we've refactored it into these 2 methods, all of a sudden, calculate total doesn't seem too scary anymore, right? At a high level, I see like, okay, well, we get the subtotal, we calculate the discount, we calculate the shipping, and then we'd run that little math formula there. That's so, and the reason why this is super powerful to me is because let's say there was a bug in calculate discount, like in the way we're calculating the discount. Well, You know it's got to be one of these 3 lines of code now. Whereas before, you have been lost in the sea of if, else if, and trying to keep track of state and all this other stuff. So just by refactoring to a smaller method, we're already getting some readability, right? We're already revealing that user's intent, what the developer was trying to do, which is a huge win. But maybe you're a developer who likes writing tests, right? If you were in the previous presentation with Eric when he was talking about behavior-driven development and behavior-driven design and how we implement that type of stuff, you may want to write some tests around this code. And so one way you could do it is maybe we extract out those methods to new classes, in this case, a discount calculator class and a shipping calculator class. And now we have these new components and we can unit test those components, so on and so forth. Awesome. So by making these small refactors, right, extract method and then extract a class, we were immediately able to improve the readability of this code. I would also argue we were able to improve the troubleshooting, the debuggability of this code. And we're actually able to make this thing a little bit easier to test, which is a huge win. So at a high level, what single responsibility principle tells us is that a class should have one reason to change. Now, in the original code sample, the calculate total method could have changed for all sorts of reasons. Maybe the discount rules changed, maybe the shipping rules changed, maybe the math formula changed, but now it's at least only doing one thing, calculates total, and it delegates the work to other components. Huge win. So how do we know that we've spotted an error, right? How do we know that we've broken something or like we've violated the single responsibility principle? Well, here's a couple of metrics you can use. If you've got classes that can be measured in hundreds or thousands of lines of code, you may be violating this, right? For those of you who've been in WinForms or WPF, you are aware that some of the generated code can totally trip into this workflow. But I've also seen business class components be thousands, and in some cases 10,000 lines of code. And it's insane to try to troubleshoot it just because it's a lot of setup. It's a lot of like Rube Goldberg machine kind of a configuration and such, and you don't want to deal with that. So very large classes could be a sign. Does the class have a lot of public methods, right? If a class has a lot of public methods, 27 is probably a high enough number if you had more than that, but it could also maybe be as high as 5. But if you have a class with a lot of public methods and those public methods don't seem to be really related to one another, that could be a sign. The canonical example for such a class is if you've ever worked with a class named something utility, something manager, right? A very vague term that all of a sudden turns into this kitchen sink object that just seems to know how to do everything. And the only reason why it can do everything is because all these methods are loosely related to one another, but not really. And then another sign you could use that's a little bit more subtle, we'll say, is a class that, well, it only has one public method, but as you go through that public method, it has a ton of private methods. Maybe not 54, maybe it's 10, 20, 30, whatever number, but it seems to have a ton of them. And especially if you get to the point where you want to start unit testing or testing some of those private methods, you might have a symptom here. But this type of class actually has a name. I call them iceberg classes, because at the top of the water, you're like, oh, that's not so bad. It's kind of cute, cuddly. We can work with this. But then underneath the waves, you're like, oh, goodness, this is a Chthonian nightmare just waiting to go. So we know some symptoms now of like maybe a code that's doing too much or maybe violating single responsibility. How can we fix this, right? How do we resolve these problems? Well, you've seen a couple of approaches already, but typically the approach I'll go through is I'll try to break the large methods down to smaller methods. So as I'm reading this large method, I'm trying to find out the steps, right? What's the narrative? You saw me do this a little bit with the calculate total earlier, right? We're like, oh, well, it calculates a discount first, then it calculates the shipping, and then, right? And then we were able to find the story, right? The high level narrative, the high points there. But once we've broken those larger methods down to smaller methods, I then get to make a decision. Do I get to move some of these private methods to new classes? If so, cool. It's usually just a drag and drop replacement. And if not, that's okay. I may leave them in there in that bigger class for right now. But the key is I've still at least made that larger method easier to read, easier to troubleshoot, easier to debug, right? And if we do happen to go to the private methods to new classes approach, we'll actually instantiate and use those new classes. This is one of the few times I'll say out loud, I can't believe I'm going to say this. Regions in C# are awesome. For this reason, When I look through a very large code base and I see like a method and's got a region around it, most of the time the developer has left a really nice like description or name for that region. Sweet, you just gave me the method name. So I just highlight that whole region, extract method, give that name, clean up some references as needed, but it's a pretty cool little trick. So just by doing these 2 refactors, you can already start breaking apart these large monolithic components, something that's a little bit easier to understand. So if you kind of understand single responsibility at this point, let's go to the other principle that's kind of a big deal. That's dependency inversion. So dependency inversion tells us that, would you solder a lamp directly to the electrical wiring in a wall? Obviously not, right? You would probably like to move that lamp around a little bit. So what does this mean for us? So at a high level, dependency inversion tells us that when we have classes, they should depend upon abstraction. So either interfaces, base classes, or abstract classes, something like that. And in addition, these classes should not be responsible for creating their own dependencies. And you're thinking, oh, okay, Cameron, why not? At some point, something's going to create these dependencies. Why can't the classes using them do that? I'll show you quite a few examples of how and why that would come up. So the reason why this is such a pain point and why we don't want to what I call hard reference these dependencies or do a hard line reference is because once we do that with a dependency, let's say we need to change it out. Well, the only way to do that is I now have to change the class, right? I have to actually go back and change constructors or actually change what's being instantiated. And the more code I have to change, the riskier it's going to be, right? If there's a series of contracts that I can follow instead, it doesn't matter what the implementation looks like, right? I should be able to use those contracts. So that's one reason why we would want to do this. Another problem that you run into if you not following dependency inversion correctly is that it's actually impossible to write unit tests around components that cross system boundaries. Here's a great example. Let's say I've got a component that does some business rules and then saves it to a file. And let's say that we're doing a hard reference to system.io. Well, unfortunately, the minute I do that, that component has now turned into an integration test or possibly even an end-to-end test. Right, but if I hadn't had taken a hard reference on system.io, maybe I'd injected in a new dependency. I could have easily been able to write unit tests on that. Another thing that dependency inversion can kind of tell us and help us out with is that by forcing us to expose the dependencies a class has, it can actually give us a hint if the class is doing way too much. And that's generally what will happen. And that's why single responsibility and dependency inversion are so tightly coupled together in this regard, right? Because the minute you start exposing your dependencies, you're all of a sudden like, wow, this thing has like 20 things it's got to need to run. That sounds bad, right? Like that's probably not a good thing, right? And so that gives us a hint with single responsibility, like, oh, maybe we should start breaking these out into other components, so on and so forth. Let me show you some examples in code now. So let's say that we had a class called order completer, and it's not the best name in the world, but it'll work. You give us an order, and what it does is it'll format a message, and then it always sends an email notification to wherever email address is associated with the order, right? Well, the problem is with this code is maybe in our bookstore, we have customers who like being notified other ways. Maybe they like text messages. Maybe they just like getting a paper receipt, right? Like we have all these other options that we could do, but given the way that the order completer is currently created, I would actually have to change method signatures. I would actually have to make some pretty heavy changes here to make this thing work with other notification types. And we'll see how to fix that in a couple of slides from now. But so here's an example where if we had dependency inversion, this would have been a lot easier. But we'll like I said, we'll see that in refactor. Here's another example of us maybe doing something that's not so great. So let's say that for I've got a component called database audit trail writer, and what it does is as business rules and business logic is happening, I'm just literally logging messages to the database, literally as an audit trail. My problem is, though, with this component is that I've taken this hard reference through a static class to log, which is kind of a bummer because if that logger.log, let's say it's logging to the database. Oh crap, well, if I want to test the audit trail writer component, I now got to stand up a database. That's not great. Well, if it's a file logger, oh crap, now I got to make sure that my file system's in a good spot. I really don't have a great way of really unit testing the database audit trail writer component, and that's a bummer, right? Because I want to be able to test. I want to make sure stuff's working correctly. So you've seen some bad code. How are we going to fix this, right? Let's talk about what we need to do. So to fix these types of issues and violations, we've got two goals that we need to follow, right? One, we got to make sure the dependency can be passed in, right? And once we have a way to pass that dependency around, we got to make sure that the dependency has an abstraction. So whether that's a base class or an interface. So to be able to make this dependency passed in and to really accomplish these two goals, we got to do the following. If the class is static, we've got to figure out a way to make it not static. And if you've worked with static classes, you're probably looking at me going, oh, Cameron, I can't just rip out the stat keyword. That's okay, I'll show you some ideas. Once we've made the class not static, we need to define an abstraction, right? And I'll show you how to do that. So, and then once we've done these things, we've got a non-static class, it's got an abstraction. We've now got to figure out a way to actually inject that dependency into our types. And we can do that in one of two ways, either through the constructor or through the method. And I'll show you some examples of that in the upcoming slides. So what's the problem with static classes? Well, the biggest problem to me with static classes is that you can't pass them as parameters, right? I can't pass them in as a method or anything like that. And they also can't implement interfaces or base classes. So I can't mock them out. I can't stub around. I can't do anything. Oh, it's super frustrating that you have to deal with this. It's really a shock to the system here. So how do we get rid of the static cling, right? How do we get around this problem? Well, in an ideal world, we would just remove that static keyword from the class or the method or whatever. However, that's not always possible because by removing that static keyword, you may have just broken your code base in half. And I don't know about you, but if I went up to my manager and essentially said, hey, look, I need to make this thing not static anymore because I saw some person do a presentation on it, I'm going to need 3 weeks to rewrite my code base to make it work. They're going to laugh at you. They're going to laugh you out of the office. They're going to maybe even laugh you out of the building, right? There's no way that's a good business move. So how can we make something not static, but also not break your code base in half? Well, we can use this thing known as the wrapper pattern, which what this does at a very high level is we define another class that's not static that literally wraps around the static class. Now that we have a non-static class that's essentially doing the same logic, we can use that to pass around. And eventually what will happen is as you have refactor components to use the non-static version, you'll get to the point where all your components are using the non-static, so you can get rid of the static class altogether. And once again, I'll show you. Let's go redo this logic. So here is the ye old logger with the database audit trail writer, and it's got that static logger, which isn't great, right? First step, let's create the interface and a public class logger wrapper. So the interface will have the same method names and type signatures as the static class does. So in our case, the static class only had one method called log, which was a void method that took in a string. So that's what the interface has. Once we have that interface defined, we create a new class called logger wrapper, implements that interface. And all the logger wrapper is going to do is in its interface implementation is it's literally going to call out to that static class. That's all it's going to do. And you're probably like, Cameron, this makes zero sense. Why are you making me write stupid components like this? Well, may seem stupid now, but let's go through the next step of the refactor. You might see why it might be a little bit more powerful. So we've now got this non-static dependency we can pass around, but how do we inject this in, right? There's two real main methods of doing this, right? You can either inject it at the constructor level or the method level. And the way to kind of determine which one's really the right approach is this kind of question I ask myself of, would this dependency need to change during the consumer's lifetime, right? So in our case with the database audit trail writer, whatever the logger is, it's probably not going to change halfway through. It's not like, well, sometimes when we call write audit trail, we need to do it to a database, and other times we do it to the file system, and then other times it's to this third-party thing, right? Because of that use case, we'll probably inject it in at the constructor level, right? Now, if we were thinking about this and we said, hey, you know what? Actually, it can change between method calls. Probably should inject it at the method level then. So in this case, we want constructor level. So we create a backing field here. We did have to update the signature a little bit. And then in the write audit trail method, instead of doing that static class reference, we're using that backing field now. Oh, snap. The minute I've got this in place, I can now start passing in mocks and stubs and actually doing some more advanced unit testing on here. I've also made this database audit trail writer unit testable. And you typically want most of your test suite to be unit tests if possible, because they're very fast, very usually easy to troubleshoot. They don't have a whole lot of dependency on state, so on and so forth. So here's an example of constructor level. Let's go back to the order completer example. So if you recall, order completer had a hard reference to the email notifier. Well, what we've done is we've now injected that iNotifier abstraction as part of the method signature of complete order. And by doing that, let's say that I wanted to do like a text notification. Okay, cool. Well, as long as the text notifier follows that contract, I can just pass that into complete order. I didn't have to rewrite all of order completer. I didn't have to rewrite that whole component just to make this work. Super cool. So here's the secret behind the reason why I started with single responsibility and dependency inversion. 80% of your issues that are coming from your code from like a maintenance, readability such, come from those two principles. The other 3 principles that we'll covers the additional 20%. And in fact, you'll see that in a lot of cases, the only reason why we tripped into one of these other principles is because we had already violated single responsibility or dependency inversion. So let's keep going. So open close principle. High level brain surgery is not necessary when putting on a hat. Essentially, the idea here is if I want to add some functionality, I shouldn't have to hack open multiple classes to make this work. I should be able to do it in brand new components, but let me show you an example of where that's not the case. So you know the good old shipping calculator from a previous example, right? You give it an order, gives you back some shipping rules, right? So in this case, we say, all right, well, if the order is going to Missouri, here's what we want to do. And if it's not going to Missouri, here's the other shipping we want to charge. But man, the cool thing about business people, right? Like your product owner, man, they always have new requirements, right? Everything's always changing. So let's say they want to do they really want to get some more money on the shipping because of the for customers ordering a low number of books from the bookstore. So we can say, all right, cool. Well, we add this new else if check, right? Else if number of books is less than 3, and if so, here's some additional rules to run. Return that result. The problem with this approach, though, is you see me kind of doing like a magician's trick here, right? I've got that / comment of additional business rules. What if those business rules were like 50 lines long, 100 lines long, 200 lines long? What if those additional business rules were actually really complicated and problematic? Well, you could run into like, how do you debug this thing, right? How do you write tests around it? It gets a little bit tougher to do all of these things. And let's say that there's more additional rules for shipping, right? Like let's say, okay, well, we want to charge this much if the number of books is under a certain number. Maybe we give them free shipping if it's over 12 books, right? All of a sudden, this method can start getting very large very quickly when it's pretty much at the whim of whatever the business rules are, right? Like whatever rules and like bonuses and set and like deals that we want to give the customer. Oof, right? Because the more you keep hacking on this class, the more risky the changes are, especially when they don't come in these nice, neat little buckets. Also, as you add more stuff and you follow the dependency inversion, you'll be like, hey, wait a minute, this class takes like 10 dependencies in now. What's up with that? And then you realize you've also violated single responsibility, but we'll skip over that for right now. So open close, right? Classes should be open for extension, closed for modification. And what this means is that if we want to add new functionality, we should do it by adding new classes, not modifying existing ones. Or if we do have to modify existing ones, it should be very, very minimal. So why do we care, right? I talked about this a little bit. So if you're modifying class to add functionality, it's totally possible you can break something downstream, right? If I'm working in a method that's 3,000 lines long and it's got tons of business cases, tons of other rules running around, very likely I've broken something, right? Because it's just too much for me to keep all up in my head. So by following open close, it forces us to create these new classes. right, to add this new functionality and then inject them in using some type of abstraction. And the reason why this is preferred is because if I write a brand new class and then I inject it in, the odds of me breaking downstream behavior go to almost nil because I just created this brand new component. There's no way it could have broken something downstream because it's self-isolated, right? It didn't exist before. So by doing this kind of like add a new class, inject it in, I'm drastically reducing the risk of making changes, which is awesome. So how do we do this? So I'm not going to lie, there's not exactly a concrete set of steps we can follow, but I find myself typically following this pattern of usually refactoring to either a factory pattern or a strategy pattern. And if you squint at them very carefully, you'll notice it's actually the same pattern, just slightly tweaked. And so what ends up happening is that the original class that had all those if, else ifs, whatever, all those components will end up becoming the factory itself. And then anybody that was using that master class will be the factory. Like they'll use the factory instead. And then all of those if, else ifs, all those like business rules, they'll become their own components. A little complicated. Let's look at code. So here's what we had before, right? The shipping calculator, calculate shipping, same business rules. So what I'm going to do is I'm going to define a new interface called an iShipping calculator. Not too bad. What it says is that if you give me an order, I'll give you the calculate shipping. And then what I'm going to do next is I'm going to define a set of components that modeled each of those blocks. So, hey, this thing's going to Missouri. Here's the class that deals all the shipping calculations for Missouri, right? You've got the rules for fewer than 3 books. You've got the rules for default shipping. And if we had to add an additional business rule, maybe you bought more than 12 books, I could just create a new class and implement all the logic there. Okay. Well, now that we've got all these various calculators, we've now got to update that master class, right? The one we had before we got to update it to be a factory. So what it looks something like this now, where it still has the if, else if, and else, but instead of all the business rules, it delegates the work to those additional components. And in fact, it actually returns those new components. So by doing this, let's say we had additional business rules, I just add another if, else, if check in here. And that's all we got to do. That's pretty cool, right? Because me adding a 1-line, 2-line of code in this, pretty hard to break that. Pretty straightforward. And so now that we've got this shipping calculator factory, we now need to go back to our original order calculator and update it. So we're going to inject in that shipping calculator factory as a constructor level dependency. And then in our code before where we had, hey, just new up the shipping calculator, we now say, hey, shipping factory, give me the calculator based on this order. And now the rest of our code works, right? The rest of that calculate total is going to do what I was doing before. And with this pattern in place now, adding a new calculator or new business rules becomes trivial, right? Because you create a new class, you make sure it implements that interface. Inside that new component, you'll implement the business rules. And then you update that factory that says, well, based on this criteria, return this new calculator. And what's cool about that is that I don't have to come back and update order calculator, right? It's totally oblivious to whatever the shipping factory component's doing, which is supposed to be, which is awesome. Because that makes me not have to troubleshoot nearly as much. I don't have to run over all the code base. I can go, oh, the problem's coming from this exact component. Let's fix that one component, which is fantastic. So we've talked a lot of stuff so far. We've talked about single responsibility. We've talked about dependency inversion. Let's talk about, I think, one of the ones that gets kind of a bad rap. A lot of people say it's hard to understand, but I think I've got a good example for you. And this is the list-cop substitution. And so what this is at a really high level is that your abstractions suck. And we'll talk about that. So the idea behind it is like, if it looks like a duck, quacks like a duck, but needs batteries, probably not doing what you need. So here is an actual way we can run into this problem. So remember, we've got a bookstore app, right? So we've got some component called book. It's got an author, a title, an ISBN, and a price. And we've got this component called inventory manager. You can already note the terrible naming here. But what the inventory manager does is it actually makes sure that do we have this book in stock, right? And if books can be ordered, we update the stock and all of that. So it's really managing what do we have in the warehouse, right? It's bookstore, it's what we do. But I don't know about you, but man, Business comes down and they're like, y'all, we've got a crazy idea. Maybe we don't have to be just a bookstore. Maybe we can sell these cool, crazy new things called electronic books, ebooks. Man, it'll revolutionize the market. And as you start talking to product in the business to understand, you go, well, an ebook's not really all that different from a regular book, right? It's still got an author, it's still got a title, it's still got an ISBN, it's still got a price, right? Now the price may be different, sure, right? Maybe an ebook's cheaper, more expensive, whatever. But otherwise, it's the same, right? They should be interchangeable. So you as a developer go, sweet. There's a lot of code that works on book already, so I should be able to leverage a lot of that. So you go ahead and do this bit where you say, all right, well, an electronic book is a book. And when you talk to product and you talk to your business, they go, yeah, electronic books are books. You're right. Okay, so here's where you get into problems. So the minute I make that inheritance, I say that book, an electronic book inherits from book. I can write code like this where I can say, hey, new up the inventory manager, create a new ebook, and then I can tell the inventory manager, hey, do we have 10 of these ebooks in stock in the warehouse? That's bad, right? Ebooks don't really have a stock like that. That entire concept doesn't make sense. But I can write code that allows me to do something I'm not supposed to be able to do. And even worse, it will compile. This is actually pretty dangerous work. I'm not even sure what it would do in this case, right? But I've now tricked my system and my application to do things it's not supposed to be doing, right? So how do I fix this problem, right? Because if it's an inventory manager, it doesn't even make sense to ever use that with a book. Okay, so here's what happens. Well, one thing you could do is you could update the inventory manager and give it some smarts about the type of book passed in. So you can do things like, well, if someone calls can book be ordered and they give me a book and that book happens to be an electronic book, yes, you can always order it, right? Always order it. And if you call the update stock, we can also do this little bit of logic. Like, okay, well, if it's an electronic book, just bail out, right? There's no reason to ever update the stock. The problem here is that I'm now having to do this type checking, this type sniffing to really figure out, can I work on this or not? And this sucks because I have to mentally know the difference between the two abstractions. And if I have to mentally keep track of the two different abstractions, I don't have an abstraction, right? Like this sucks. This is not great. So what can we do instead? Right. So the problem at the high level, and at the end of the day is that typecasting, in order to perform one set of logic versus another, is a really bad abstraction. In fact, Jeff Atwood has written a really great blog post about this idea of leaky abstractions, the fact that you're trying to code to a contract or something and it doesn't really quite work. And the reason to me why this is such a big deal is that I'm a huge fan of preventing developers from writing code that shouldn't work, right? I like leaning on the compiler for finding the errors for me. I don't care so much that it helps me find missing semicolons. I care a lot more that it says, hey, wait a minute, you're trying to pass an ebook into something that like doesn't have stock, right? I want it to catch those type of stuff for me. So by defining our type system a little bit better, we can do a better job. So let's talk about this. So how do we fix this stuff? At the end of the day, the problem is that not all books are created equally. They're not the same thing. We've determined that a book and an ebook are two very separate components for a lot of our code base, but for a lot of our code base, they are the same. So what can we do? Well, let's change our abstraction just a titch. Let's define a new type, and we call this a physical book. It also inherits from book. So you've got an ebook that inherits from book, a physical book that inherits from book, okay? The minute we make this change, we can go into our inventory manager now, and we can change its type signature to say, no. I don't work on just books. I only work on physical books. The minute we make this change, the compiler is going to prevent me from ever trying to pass an ebook into these methods. Nice. That was the problem we're trying to solve. Now, that does mean we have pushed up this kind of decision logic up a layer, right? Like whatever component calls these methods kind of has to know now. But what you'll find, and I actually think this is pretty cool, is as you go up the layer and you start making things have to be smart about the types, you'll actually find out that there's actually completely separate workflows that need to happen. Like, oh, well, if you're purchasing an ebook, like 5 of these components don't even matter anymore. And the minute you find yourself doing that type of code, you should probably use something like a strategy pattern to say like, oh, well, if you're purchasing an ebook, do all of these steps versus a physical book, which is all of these steps, which coincidentally actually makes it a lot easier to troubleshoot stuff, right? Because if a customer calls in and says, hey, I can't buy a physical book correctly, you're like, well, I know it's got to be in this set of flow, so you can ignore the other. It's kind of convenient that way. So at a high level, right, list-off substitution tells us the following. If we've got these two classes and we say they derive from the same abstraction, so in our case, ebook and book, then I should be able to interchange them, right? And that wasn't the case in our example. So if I say that these two things come from the same abstraction, they should be interchangeable. My calling code should not care. Cool. We're almost at the home stretch, y'all. Interface segregation principle, the last principle. You want me to plug this in where? So let's talk about the inventory manager a little bit more, right? We had the can book be ordered, we have to update stock, and now we have this order more, right? So this is the, hey, we're almost out of stock. Let's order more from the warehouse to get it here, right? Cool. So we've got that. And let's say somewhere else in our code base, we've got this method called add physical book to order, maybe because we did some list-off substitution fixes. And we've got this code that says, all right, well, we new up the inventory manager, we check to see if the book can be ordered. If so, we update stock, blah, 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 blah. But here's something I can do here as well. I can, since I've newed up the inventory manager, I can also call its order more method. And you're like, wait a minute, time. I shouldn't be allowed to do that. Why do I have access in this method to be able to call order more? That should be something that's being handled behind the scenes, right? It should not be available to me in this workflow. It still needs to be a public method, right? Because there's other parts of the application that should be able to call order more, maybe the inventory system, right? The inventory module. But why can't I do it here? Sounds so great. The problem is, at a high level, is when we designed that inventory manager, we pretty much gave it a list of here's everything it can do and not what should it be allowed to do. For those of you who come from a C background, you may remember header files, right? So the idea is like when we define our interfaces, we should be thinking about like not here's a list of everything it can do, but here's a list of things it can be done in these different contexts or these different roles. Let me show you. So the first thing we're going to do is we're going to make one role that says, okay, here is a role. Here's all the things you can do if an order is made. Here's the method you're allowed. And then we'll define the interface for those required methods, and then we'll update the inventory manager so that it implements that new interface. And now once inventory manager has that interface implemented, we can update the client code to only use that role-based interface. So in our case, we made an interface called iInventory Tracker. So we're saying, hey, if you need to use, if you've got an iInventory Tracker, that role lets you do the following. You can check to see if a book can be ordered, and you can check to see if you can, and then you can update stock. That's all you're allowed to do. Because we follow the same signature as inventory manager for this, implementing the interface like this is trivial. We literally just do iInventory Tracker. Here's the magic now. The minute inventory manager implements that interface, even when I'm newing it up right here, I can, like once I new it up here as an iInventory Tracker, for all intents and purposes, that inventory tracker only has two methods, can book be ordered, update stock. It can never see that third method, even though inventory manager totally has it still. You was actually able to hide those things, which is pretty powerful. For those of you who've been in WinForms or in WPF development, or sometimes just doing some of the stock Microsoft components, have you ever worked with a class and you did dot and then IntelliSense pops up and it gives you like 50 million things you can choose from, but you know in reality there's only like really 5 you should be touching with at that point? That's an example of where a good interface wasn't defined there, right? It gives you way too much power, way too many things that you can do, which you probably shouldn't be able to. So I know we covered a lot of stuff, so let's kind of put the bow on this real quick, right? So in this presentation, we talked about what is solid, right? We talked about where the principles came from, the mnemonic, all of that. We talked about some of the advantages of our code being solid. We talked about what they stand for, how to spot issues, how to fix them. And I know this is a lot. So if you walk away from this presentation and you only remember that solid helps us by preventing us from doing too much stuff and prevents us from writing crap abstractions, that's it. That's the key principle here, right? That's the problem it solves. So you want to know more. I posted this in the Discord channel, and I'll also post it here as well in Teams. But I found the following resources to be super helpful. From a book perspective, Working Effectively with Legacy Code by Michael Feathers. That's actually where I got the wrapper trick from the static class thing. Super awesome. Don't read it cover to cover, but it's definitely a great like follow your own adventure book. Refactoring by Martin Fowler is kind of where a lot of the extract method, extract class techniques came from. If you're a Pluralsight subscriber, Steve Smith has a fantastic course called Solid Principles of Object-Oriented Design, which I believe he's updated recently. And in that course, he goes deep into all of these principles, right? I had to cover all this stuff in 45 minutes. He like spends a couple hours on just dependency inversion, right? So that's where you're going to really get in, like to the meat of all this stuff. And if you're wanting to learn a little bit more about header interfaces versus role interfaces, Martin Fowler also has a really great blog post on it. Oh, goodness. So I guarantee there'll probably be some questions. So here's how we'll pretty much do that. We'll obviously have the chat open for a little bit here, but I'll be hanging out in the Discord channel, in the Nova Code Camp Discord under track, etc. So you can always meet me there and we can chat about stuff. Let's say you're not on Discord, don't want to be in Discord, that's cool. You can always email me at cameron@softwarementor.com and I will get back to you with whatever questions you got and try to help you out. And the last thing I'll ask is, do me a favor. I'm always looking to improve, get better, kind of sharpen these presentations, and given doing it remotely, feedback can be a little bit interesting. I've also posted the link to this survey in Discord, but I'll post it in Teams as well. It's a one-question survey, just a very quick, like, hey, how do you think I did? And if you want to leave your email and some more details, you can, but not required. But overall, thank you all so very much for letting me speak today. Had fun, and I'm looking forward to answering some questions.
So great, Cameron. Thank you very much. So we do have a question in the Q&A. Anonymous asks, when to choose composition over inheritance? Your example of physical book versus ebook. You made a physical book and ebook inherit from book. Would an alternative approach be an iStockable interface, which physical book implements, but ebook does not? For example, physical book, iBook, iStockable, and ebook inherit from iBook.
Yeah,
that question is in the Q&A if you wanted to see it again.
Oh, sure, absolutely. Sorry, I'm shuffling like everyone else, right? We're all shuffling a couple of questions here. Yeah, so as I'm trying to get the pulled up, I can go ahead and answer though. You could have totally gotten away with an interface on that, no problem. It would have changed the implementation details of a few other things, but still that concept, right? Like we defined a new type, and by defining that new type, we're restricting what can be called and what can be passed into it. So yeah, absolutely.
Great. Are there any other questions from users? Again, feel free. We are in the Q&A session, so if you have a question, please go ahead and type it into the live event Q&A. We'll wait here a few seconds more to see if there are any questions. If not, we will. Cameron will be heading over to the track dash etc. channel in Discord, and you can find him there. If not, thank you, Cameron, very much for your presentation, and we look forward to continuing over in Discord. For everyone else, you can just hang out and we'll get on to the next track in about 10 minutes. But thank you very much, Cameron.
Thanks, everybody.